Okay, so thank you for everyone for getting out when the fire alarm went off. Obviously, it was a glitch. What question are we on now? Number 5. What does it mean to have a high specific heat? I think it's heat index is on here, so I think that's the one where it says water has a high heat index. That's the same thing as specific heat. Okay, let me run so fast. Did anybody get number 5 yet? Okay, go ahead, Chad.
It absorbs a lot of heat before it begins to get hot.
Okay, right. Water has a high heat index. It absorbs a lot of heat before it begins to get hot. This is why water is valuable to industries and in your car's radiator as a coolant. The high heat index of water also helps regulate the rate at which air changes temperature, which is why the temperature change between seasons is gradual rather than sudden, especially near the oceans. So we live in a desert. Obviously, we don't have any oceans. But if you go to the West Coast or the East Coast, which ocean is on the West Coast?
Pacific.
And which ocean is on the East Coast? Very good. And that's why it's probably more humid in the Midwest than the East because of they're close to water. We're in the desert, so we're dry. Okay, I'm gonna give you guys a few minutes to catch up. Do 6 and 7, and then we'll go over those together. If anybody has any questions or needs help, I'm just gonna walk around, raise your hand, and I'll be more than yes, ma'am.
My mom actually lived in Kansas for a couple of months. She heard people bitching about the heat over there. She looked at them directly and said, "Go to Arizona. We got dry heat."
However, I lived in the Midwest. I grew up in Illinois and Iowa. The heat in the Midwest is different because it's humid. So when you walk outside,
it's wet.
It's wet, so it's like you feel like you're sweating, like you just got out, you're like you're in the shower. Yeah. Where here it's just hot. So it's kind of, I'll give you the example, I'll explain it. Being in the desert heat is like being in an oven. Being in the Midwest heat is like being in a sauna. So if you know the difference between a sauna and oven, that's how you can explain it. Because you know when you're in a sauna, you're sweating, it's real moist. When you open the oven, you just get that whoosh of heat. So yes.
As someone who grew up in Michigan when I was younger, the summer was super humid. So
right. So that's so right. So when I grew up in Illinois, it would be maybe 95, but the heat index would make it feel like 115. So it would just be like, ugh, you just didn't want to go outside because it was just unbearable. Okay, so we have 2 more questions on facts about water, and then the next unit is universal solvents. So, did anyone get a chance to answer number 6? What does it mean to have a high surface tension? Maddie?
Water has a very high surface tension. In other words, water is sticking elastic. It tends to clump together and drops rather than spread out and thin.
Okay, good. So water has a very high surface tension. Water is sticky and elastic and tends to clump together and drops rather than spread out in a thin film like rubber and alcohol. Surface tension is responsible for capillary action. What does capillary action do for plants and animals? Okay.
Allows water to move through the roots of plants and through the tiny blood vessels in our bodies.
Good. So capillary action, which allows water and its dissolved substances to move through the roots of plants and through tiny blood vessels in our bodies. So that's why it's always good to have water. Water's not the best tasting thing because it tastes like nothing, but it's good for you. It also makes you go to the bathroom a lot, which I don't like, but I still drink it. So go ahead and do universal solvent, answer questions 8 through 12, and then we'll go over those together.
This is universal solvent, left hand side of your screen.
Go back to the first page. Okay.
Did anybody find?
I don't see it.
It says it's on the left-hand side of the
Click
screen.
it's blue in the, reading article, so click it where it's at, then you can go to the page.
Wait,
What?
could you show us?
You go back in here,
Oh. Go back to facts about water.
and then you go universal solvent.
And go to universal solvent. So go back to facts about water. Yeah. Right, you got it? So go back to facts about water.
Yeah.
So it's the fourth question that we answered about universal solvent. That's what you clicked. Thank you, Tiffany.
Thank you.
Or did you get it, or you're not there yet? My fat finger's clicking right there. Okay. So you might have to do that for cohesion and adhesion. I don't see that. Okay, did anybody get to number 8 yet? Why is water called a universal solvent? Maddie?
Because it's capable of dissolving more substances than any other liquid.
Because it's capable of dissolving more substances than any other liquid. Very good. Okay, number 9 says, why is water being a universal solvent important to living things? You wanna find that one yet?
Yeah, I think so.
Tiffany?
It means that wherever water goes, either through the air, ground, or through our bodies, it takes more valuable chemicals, minerals, and nutrients.
Will you tell us where you found that answer again? That was very good. Just
It's in
paragraph.
the first. Yeah.
The bottom.
Oh, okay. So it says this is important to every living thing on earth. It means that wherever water goes, either through the air, the ground, or through our bodies, it takes along valuable chemicals, minerals, and nutrients. Oh, I see it. It's in the next paragraph.
Okay.
So the polar arrangement can be found in the second paragraph. So it says, what is a polar arrangement? Chad, did you get number 10?
I think I put oxygen, hydrogen atoms.
Right, water molecules have a polar arrangement of oxygen and hydrogen atoms. One side is hydrogen, has a positive electrical charge, and the other side, which is oxygen, has a negative charge. This allows the water molecule to become attracted to many other different types of molecules. Okay, so number 11 and 12 are in the next 2 paragraphs, and then we'll have to move on to cohesion and adhesion. Tiffany, how do we get to that? Thank you. Because it says it's on the left-hand side of the screen, but I don't see that. Do we have to go back to maybe water properties topic?
I think so.
You 2 twins today. Oh yeah, it is. So when you go back to the home screen, it says adhesion and cohesion. Did you see it? Tiffany? Okay.
number 11.
So Aiden's gonna be nice, and he's gonna answer number 11 when he gets done. So number 11 is, explain how kidneys filter water and how the universal solvent property is important in the process.
The kidneys are responsible for filtering out substances that enter our bodies from the foods and drinks that we consume.
Correct. So that's what your kidneys are responsible for. So filtering out substances that enter your bodies from foods and drinks. So that's why when you eat too much of the wrong thing, or sometimes drink too much of the wrong thing, you have issues with your kidneys. And then number 12, explain why salt dissolves in water so easily. So salt dissolves in water due to electrical charges and due to the fact that both water and salt compounds are polar, with positive and negative charges on opposite sides in the molecule. So then there's a picture of the water molecule, and then you can see the salt in the water. So when you put sugar in water, what does it do? Where does it go? To the bottom. So the same thing with salt. When you put it in there, it goes to the bottom. But if you notice, like if you're trying to make iced tea, and you have to put the sugar in there, you have to keep stirring it because it all goes to the bottom. So when you drink the tea, all your sugar is at the bottom. Me too. So I don't like, because we used to make, when I was younger, we used to make a bucket of tea and you pour all the sugar in and go on the bottom, so you have to switch it around to get the sugar in there. So cohesion and adhesion is just 3 questions. Then the next unit is capillary action. You guys are doing a wonderful job of working diligently. You guys are working together, helping each other out. I appreciate that. Did you find the next one? Yeah. Who's still working on number 12? Okay. So I'll give you a couple minutes, finish that up, then go to the next unit. Anybody get number 13? Jackson.
Water is attracted to water.
So water is attracted to water. 14, adhesion. Aiden?
Water is attracted to other substances.
Right, good. Water is attracted to other substances. Anybody get 15 yet, or are you still working? We knew water is attracted to water, that's crazy. To explain how cohesion and adhesion create water droplets that stick to things. Anybody figure that one out yet, number 15? No?
I didn't know there were more too.
So it says, gravity is working against both adhesion and cohesion, trying to pull the water drop downward. Adhesion and cohesion are winning the battle so far as the drops are sticking to the pine needle. So the water drop is composed of water molecules that like to stick together. And the water drop in the picture is stuck to the pine needles. And did you get 15 yet?
Did I get 15? I think I found.
What did you put? Cause I think could be different answers, so what did you get?
I put down gravity's working against both of them trying to pull the water drums downward. I don't know.
Okay. Anybody get anything different for 15? Chad?
Water is highly cohesive.
Okay. Anybody else? Jackson?
It occurs during the lowest energy state, the state where the atoms in the molecule are using the least amount of energy.
Where'd you get, which paragraph?
It's right here.
Oh,
Cohesion
cohesion
makes
makes
a
water
water
drop.
drop.
Oh, okay. I think you can, the natural form of a water drop occurs during the lowest energy state. The state where the atoms in the molecule are using the least amount of energy. Yeah, I think there's a couple different answers for that one. Cause it's kinda hard to figure out, so. I think if you're, talking about cohesion and adhesion, you'll be fine. So if you go back to water properties topic, then go to left-hand side and it should say capillary action water. So you should see capillary action water trees, a picture of some trees. So then do 16 through 19 for that one. First question is, what is capillary action? So I got, what is capillary action? It is defined as the movement of water within the spaces of a porous material due to the forces of adhesion, cohesion, and surface tension. Okay, so we have about 3 minutes before class ends, so if you want to go ahead and finish capillary action 16 through 19, and then you might want to finish the rest of it for homework, but if not, I think we'll finish it tomorrow in class. So if you have any questions, let me know.
Okay.